Is our universe infinite? Sooner or later, many of you will certainly ponder this question. Unfortunately, today's science cannot provide a definite answer. However, it can confidently state that the universe had a beginning. The world we know has been evolving for 13.8 billion years, starting from what is known as the cosmic singularity. To study this process, astronomers have to literally look back into the past. Hello, and welcome to Z. Please don't forget to subscribe and hit the bell icon. When we talk about the universe's boundaries, we only mean the limits visible to us. This visible area is called the metagalaxy or the observable universe. But what lies beyond? The idea that the universe has boundaries is one of those profound concepts that can dramatically alter our world perception. A similar event occurred in 1543 when Nicholas Copernicus proved that Earth wasn't the center of the cosmos. Another breakthrough happened in the 20th century when Edwin Hubble showed that galaxies move away from each other. This led to the idea that the universe hasn't always existed and was formed by a specific event, the Big Bang. Today, we know that the dimensions of our world are much larger than we can imagine. The search for answers about its boundaries is poised to lead to another scientific breakthrough. Currently, scientists can only discuss the boundaries within which objects are visible. This area is also known as the observable universe, the part that is the absolute past in relation to the observer. The cosmic horizon marks the boundary of the observable universe. Objects on the horizon become infinitely redshifted, constantly moving farther away. The number of galaxies in the observable universe is estimated to be over 500 billion, increasing regularly as research equipment advances. But how large is the observable area of the universe today? The distance to the farthest observable objects is approximately 14 billion parsecs in all directions, making the observable universe a sphere with a diameter of about 93 billion light-years, centered within the solar system. This area equals 350 quintillion cubic meters. The light from the most distant observable objects has been traveling for 13.8 billion years to reach us. However, the distance to these objects has grown significantly due to the universe's constant expansion. This process results from the presence of matter and energy in space, filling space-time. While there is matter in space, gravitational force exists. Therefore, the universe either shrinks due to gravity or expands due to dark matter. It's also notable that there isn't a single center for the universe's expansion, just as there isn't a space for the universe to expand into beyond its boundaries. This process occurs with matter in space at any point, everywhere, and at all times. We don't physically perceive this because the force holding our atoms and molecules together prevents us from bursting under the influence of space expansion. This can be compared to a loaf of bread baking, with the raisins representing galaxies and the dough representing space matter. Estimates indicate that the distance to the farthest observable objects today is about 14 gigaparsecs, or 46 billion light-years. The farthest stellar system from Earth is a galaxy called GN Z11, whose light has been traveling to us for about 13.4 billion years, meaning it was formed less than 400 million years after the Big Bang. However, due to the universe's constant expansion, today's distance to GN Z11 is approximately 32 billion light-years. One might argue that its recession speed exceeds the speed of light. But it does not contradict the special theory of relativity because it isn't the matter receding, but the space between the objects growing. This object is thought to be one of the first galaxies and likely the closest stellar cluster to the edge of the observable universe. If humans could travel freely between worlds, it is in that galaxy that we might learn more about the genesis of our world. The metagalaxy likely began expanding immediately upon its birth. Theoretically, the boundaries of the metagalaxies might reach the cosmic singularity, potentially showing what the world was like before the Big Bang. However, in practice, relic radiation marks the limit to the observable universe. This radiation, emitted by the farthest objects in the universe, creates a barrier to our vision. It emerged about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form. Essentially, it is an image of space in its infancy, before the first stars formed. The universe likely stretches infinitely beyond this barrier, where its hypothetical boundaries lie. Objects beyond this barrier are referred to in various ways, such as multiverse or parallel universe objects. Science today cannot define these bodies in detail. However, assuming the universe continues to expand, we can conclude that the objects we observe now will eventually disappear from our field of vision. If the universe's accelerating expansion continues indefinitely, galaxies beyond our supercluster will eventually recede beyond the horizon, becoming invisible. Any form of communication beyond the observable universe's boundaries will become impossible, and contact between objects will be lost. The Earth, Solar System, Milky Way, and our supercluster will remain mutually observable, while the rest of the universe recedes. There may be hypothetical worlds beyond the regions observable to us, resulting from phase transitions of physical vacuum or forming out of irregularities in relic radiation near the particle horizon. The question of multiverse objects is contentious among scientists, prompting many pseudoscientific guesses. Nonetheless, most researchers agree on the universe's infinity, though they interpret it differently. Some claim our world is multidimensional, making our three-dimensional universe just one of its layers. Others believe in a multi-universe theory, with us as a tiny fraction of an infinite multitude. There may be a portal to other worlds beyond the observable universe. Some space theories involve the sacred event horizon's existence. According to this concept, we will never see beyond the event horizon because the speed at which photons travel away from us will exceed the observable universe's expansion rate. All surrounding galaxies will eventually recede beyond the event horizon, appearing as if time has stopped in them. We will see them infinitely receding beyond the observable boundaries, but never completely disappearing. Contemporary science cannot provide a definite answer to this question, although this may change once we develop more advanced observation equipment. The universe might be a sort of sphere, making traveling over it similar to traveling on Earth's spherical surface. However, considering its scale, this seems impossible. Reaching the edge of the observable universe would take 46 billion years, even at light speed. By the time we reached this point, it would have moved the same distance away, necessitating a similar journey. It is likely there aren't any large objects beyond the observable universe, and peering there would reveal only a homogeneous cloud of helium, hydrogen, and a few other elements. However, we may never discover our world's origins, and may always be like someone chasing the horizon. I hope you have enjoyed this video. If so, please like and subscribe to avoid missing new videos. Keep in touch. The question of what lies beyond the observable universe touches on some of the most profound mysteries of cosmology and physics. The observable universe is defined as the region of the universe that we can see or observe, given the finite speed of light and the age of the universe, approximately 13.8 billion years. Beyond this observable region, however, lies a vast expanse about which we can only speculate. Several theories offer different perspectives on what might be out there. 1. More universe. The extended universe hypothesis. The most straightforward idea is that the universe continues beyond the observable limit, much like it does within it. According to this hypothesis, the same physical laws and structures that we observe in the observable universe, galaxies, stars, cosmic microwave background radiation, extend indefinitely. If this is the case, then there could be countless galaxies and perhaps other phenomena beyond our current observational horizon. 2. Different regions with different physical laws. Multiverse theory. Some cosmologists propose that what lies beyond the observable universe might be regions where the physical laws differ from those we know. This idea stems from the concept of the multiverse, where our universe is just one of many bubbles within a grander multiverse. These other universes could have different constants, particles, or even dimensions, leading to drastically different physical realities. 3. Inflationary multiverse. Linked to the theory of cosmic inflation, the inflationary multiverse suggests that during the inflationary phase shortly after the Big Bang, different regions of space expanded at different rates. This could mean that our observable universe is just one patch in an infinitely larger and diverse cosmos. Each patch, separated by vast distances, could have undergone its own unique inflationary process, resulting in varying cosmic properties.
Vierter Paralleluniverses.
Another intriguing concept is that of parallel universes, where there might be an infinite number of universes that are spatially separate from ours. These universes might exist in higher dimensions beyond our three-dimensional perception. This idea, often tied to string theory and quantum mechanics, suggests that our universe could be one of many parallel realms, each with its own distinct characteristics. 5. Mathematical universes. Max Tegmark, a physicist, has proposed the idea of mathematical universes where every conceivable mathematical structure exists as a physical reality. In this view, the observable universe is one realization of a particular mathematical framework, and beyond it lies an infinite array of different structures governed by different mathematical laws. 6. Boundaries of our knowledge. The limit of human perception. A more philosophical perspective suggests that beyond the observable universe lies the limit of human perception and knowledge. Since we are constrained by the speed of light and the age of the universe, there may be fundamental boundaries to what we can ever know or observe. This boundary is not necessarily a physical one, but a limit imposed by the nature of our observation tools and methods. 7. Dark flow and anomalies. Some observational anomalies, such as the phenomenon known as dark flow, where galaxy clusters appear to be moving in a consistent direction, hint at the possibility that there are large-scale structures beyond the observable universe influencing these motions. These anomalies suggest that there might be unknown gravitational influences or other phenomena beyond our observational reach. Thank you for watching and see you next time.